So I'm a project manager. He's a developer, architect, software developer, and it's really about presenting a practical case, a project we just did with, of course, open source solution. So what we talk about the context of the project, the goals, the challenges, and then show you some first results on a solar cadaster use case. Just a little bit about methodology and in particular UX and UI design, see how we work. And then in the last part, Ben will present the software architecture for this virtual city map solution that we've been using for the 3D mapping. All right, so you know Camp to Camp. We've been working in FOSS since 2000, I think, so it's more than 20 years. And, okay, not much to say. And Virtual City System is a German company, and they specialize in 3D city models and urban simulation. So you may have heard of them as well. Okay, so Rennes Métropole is quite an important city in France, in Brittany. It's about 200,000 people, the city itself, but it's 500,000 people around total. And they do have a lot of data. They call it a digital twin, but it's really very different data, various types of data. And not depending on any solution, they really want this data to be used for different subjects, basically manage public policies and to be able to collaborate with professionals in the city and make support decision. A lot of things. Rennes is really a French city, well in advance in all this question. So our project was really about cooperation with citizens. It's also something Rennes is doing a lot, is trying to involve citizens in public policies and decisions. So, yeah, I just put a small map here. You can, for those who don't know, you can see where Rennes is in Brittany, right there. And the project was to develop a participative portal offering 2D and 3D visualization based on their city's digital twin. And they wanted it based on open source solution. Also, Rennes is a city that supports a lot open source solutions, and it has to be integrated in their IT infrastructure. So that was the general goal of the project. And it was a little bit more centered on 3 use cases. So a use case where anybody could go on the platform and make a simulation of the photovoltaic production potential on your roof, on your house. And this is the one I'm going to show a little bit after. But we worked also on 2 other use cases. Rennes has a big project of new tram bus lines in the city. So they want to present the line, how they will change the landscape and how people will move inside the city. And then they want to open consultation to the citizen so citizen can react to the project. And finally, a 3rd subject about what is the exposure to electromagnetic waves. So normally at the end of the project you will be able to see where are all the antennas, what are the levels of electromagnetic wave exposure. What else also? Just to mention that Rennes is also an interesting city. The Rennes Métropole is actually 48 different small cities, and they always manage to keep green areas and agricultural land inside. So it's good, but on the other hand, they have problems with transportation and also, of course, with energy production. So that's why they are really concentrating on these use cases. Okay, so what were the challenges for this project? The first thing was co-construction. Like, I don't know what is your experience. If you have, is anybody here a project manager in the room? Yeah. So This project is not about developing new feature in Cesium or Virtual City or OpenLayers. It's really about how can we build something that is useful for the city, for the citizen, and really the general public is the end user. So that means that we cannot come and say we have this nice solution, so take it, it works, and take it as it is. You really have to design something that is corresponding to the public need. And it has to be performant and reliable, because most people don't have any patience. After 2 seconds, they switch to another website. Okay, just to show you the first results here. And that's really simple. People just give their address, so we can spot the building, and we can simulate the energy, the solar energy that can be produced with this roof. So for doing this, we have all kinds of data that are actually prepared by Rennes Métropole. And here we're using Cesium, OpenLayers, and it's really designed as they wanted it. And the second step is you can actually simulate your installation. So sorry it's in French because it's French city, but the idea here is when you select a roof, and the system will tell you which is the best roof for your installation, and of course it's the south roof usually. And you will have here the opportunity to specify where actually you cannot put some solar panel. So the next here, like in this test, we say, okay, I cannot put any solar panel in here because for any reason it's not possible. And then the system will simply suggest an optimized installation of panel solar system, and after that you can come back and maybe change a little bit this. But it's really anybody can go on the website and make some simulation and change. After that you can change the number of panels and do whatever you want with this installation. And in the end you get a report. You get here, it's in French of course, but you can guess. It gives you how much energy you might be able to produce and how much energy you can actually resell. So all of this, you can imagine, has been, all this design is the results from a lot of workshops with the clients, a lot of discussions, a lot of UI, UX design. And we started the project 1 year ago, and I think I don't think we have coded, maybe we have been coding for six months only. So the first 4 or 5 months were just designing the system. So how we did this really is encourage cooperation with the participative approaches and with the people at Rennes Métropole, but also we invited general public to test not the real thing, but the, how do you say that? Yeah, okay, the mock-ups and stuff. Also, of course, we are used in Come2Come to deploy open source solution, and that's the heart of our job, is to take OpenLayers, to take Cesium, to take Virtual City Map, and build something that is really the closest solution to what the public wants. And then also we rely on a partner, Virtual City System, who is really a European leader in open source digital cities. Just a few words about design, just to explain that. We followed these 5 steps. First of all, just framing with basically talking to the stakeholders and trying to understand exactly what do you want to do, what is the context of the project, what users, what are the risks and everything. Then a research phase when we actually interviewed the general public, the users, the business experts and everything to get to integrate their point of view. And then finally, to get from this a minimal viable product. So again, at each steps, It's a lot of workshops, discussion, iteration, to finally get to the design cycle where we do wireframes, sketches, and in the end, user testing to see that the prototypes were okay. So just to give you an example, when we first show this, I think, when it was just a mock-up, people didn't know what they were supposed to do. What do I do with that? And they did not realize that they have to type an address here to find their house and everything. So here is not the homepage, but we have to redo the homepage and give them more information to the public how to use it. All right. So basically, there was a lot of work, design and integration with Figma. I don't know how many people use Figma in their project, and yeah, quite a few. So at Com2Com, it's really something we are integrating in our project development and design. And you can see here, the design usually looks like the pages I just showed before. Then maybe it's time to talk technologies with Ben. So as we said, we relied on OpenLayers and Cesium mostly. Sometimes just OpenLayers, sometimes just Cesium, but a lot of time on Virtuosity map solution, which is open source now, and Ben will explain it.
Yeah, I'll try to at least. So, as Frederic said, we use OpenLayers and Cesium, and then we created a wrapper around it. And in the end, it's a JavaScript project. There are libraries. We've put them open source 2 years ago. And we've kind of decided to have a multitude of approaches. So we provide a core functionality, which is the GIS library, which helps you render your data, and a UI that we build on top that is basically what we sell to our customers. So the UI is also open source. And we had long discussions also with Frederic and with Camp2Camp on how we're going to approach this, because they had such a strong idea of how their UI has to look. We actually ended up just using the core functionality from the Virtual City Map core and have them design their own UI on top of that. Because, like Frederic said, the challenge of meeting the general public in a very specialized environment is very difficult. So the UI has to lead the user way more than our UI, which is more targeted to expert users. So we've implemented the VC Map core, which provides you with some abstractions to make it easier and faster to develop GIS framework or WebGIS applications where you require both 2D and 3D data without the need to really fully understand OpenLayers or fully understand Cesium, because they have two very different approaches. So what we did, the first thing we did is we decided that we're going to define what we call maps. In the end, they're just renderers. So we use OpenLayers to render 2D, and we also have an oblique view, which is something we do a lot in Germany. So they're aerial oblique imagery that we process, and then you can view them in custom reference frame also in OpenLayers, or rendered with OpenLayers. And we use CesiumJS to render 3D, which has been working very well for the past 10 years. But it's possible to change these abstractions. We've had maps that would work in panoramic view before, so this is a custom solution, and you can plug them into the system and it will just work. So that's viable to provide a leaflet render if you would rather use that. And for your data, we just find it in layers, because that's basically the GIS structure, or how GIS people think. We think in layers, so a data set will be turned into a layer and I want to render it. This is how I'm used to doing things. This is not the way that Cesium sees data. So we've abstracted it into layers and provide you with the functionality to render your data in 2D and 3D. Sometimes, or the things we define, will do this automatically. But there are even ways that you say that your data should look different in 2D than 3D. A general idea is that you have actual 3D building streaming data, and in 2D you would need to represent it as footprints. But to do this for an entire city can be difficult, so you would rely on vector tiles for the 2D data and on Cesium 3D tiles for the 3D data. And with the layer abstraction you can do that without having to think about it too much. So you just define, okay, this is my vector data, it's here, and this is my Cesium 3D tile set, It's over there. You plug it in and it works on both maps, and you can switch in between or render it side by side, and that will just, it will work, right? And the other thing that is very different between the two engines is how they handle interactions, pointer interactions from the user. And so we've tried to abstract that as well, just to make it easier to select a feature in both maps, or draw something in both maps, or select a bounding box in both maps. And we did some work into generating styles that work on both data sets. So we decided to use OpenLayers styling language most of the time, but you can also use Cesium's declarative style and apply it both to vector data sets or Cesium 3D tile sets. And one cool thing that we thought of that a lot of our customers have is they have a lot of 2D data where they have some information that would give them a rough 3D interpretation of the data. So maybe you have your footprints and the height of the building. So in 3D, you could render a cube. And we can do that very easily by defining certain attributes on your data, or mapping your data to those attributes in a pre-processing step, so your 2D data actually renders as 3D data in 3D and as footprints in 2D. This also makes it easy to place models at certain locations without actually having to render instanced models over Cesium 3D tiles. So you can just have a GeoJSON which references certain models, and you could have trees in your city or benches or whatever. Because typically our customers don't have instance 3D model tile sets. They have vector data with points and some attribute mapping saying this is a tree and it's 12 meters high, and we can then render that as a tree in 3D. And of course we support true 3D formats like Cesium 3D tiles and GLTF. And then we have some perks that are interesting for a lot of our use cases, but I think also other use cases can benefit from this. Our map has a state, or the application has a state that can be serialized and deserialized. So the layers I've configured can be stored on multiple servers or pulled into an application and loaded at runtime. And I can change the configuration and serialize it again. So it's not like an OpenLayers map, which is more hard-coded. You can easily build an editor on top of it to configure your application and make it very versatile depending on the data your customer has. Or maybe even write a workbench that once the data is processed, your map will also be updated to include the new data. There's an editor which gives you high-level access to interactions, so you can draw stuff. That's just something that a lot of our customers require. They need to draw stuff. They need to even extrude it sometimes, so they maybe need to draw a cube. You can write your own custom implementations, like I said, of layers or maps, even different renderers. And there's a UI, so if you're not someone with so much experience in designing applications and you just need it for your research project, you can easily just use our UI and build on top of that. It's also pluggable. The UI, you could build your own interactions and your own windows and just plug them in. And that's about it, and I think we're on time.